Good morning, everyone. Welcome to SQL Server table partitioning session today. I'm Maggie, and I'm happy to be here. Hope you also, and you have a great experience in this incredible conference with Avatar Land. That's really exciting, and this is something that we will enjoy a lot these days. So today I'm going to talk about table partitioning, but not just table partitioning as a feature in SQL Server, because probably many of you are really familiar with table partitioning. But what is important to consider for when we use table partitioning is when to use it and when to just avoid it, for example. And last but not least, the second important point is how to perform an implementation of table partitioning in your databases so that you achieve the goals and you prevent the potential performance issues to occur, because that happens quite often with partitioning. So we have to, when we choose partitioning, we have to be sure that we implement it correctly, and we have to be sure there is everything is optimized. So this is really, really important. So today, I'm starting with a quick introduction to table partitioning, and then I'm going to switch to my demos so that we see the step-by-step process of implementing of table partitioning and specific do's and don'ts, what we should do and what we should not do, and pay attention to when we do such an implementation. So what is table partitioning? Table partitioning is just breaking a single table horizontally, or index, let's say, but we think about a table. So we just split a table in horizontally into multiple structures. So, of course, there should be a criteria to do so. So we require, we have to choose a single column, which we use as a partitioning key. So that column is very, very important to consider, because this column actually is one of the key choices when you decide how to perform a table partitioning. So it's not just I have a big table with, let's say, billions of rows, then I should partition it. Well, that's probably a first thing that we start with, but we have to consider what should we do, how to perform that, and which column to choose as a criteria, because this column should actually not be used just as a partition key to split the data in a separate physical structure, but this column should be part of our where clauses, our select queries, which we run on against that table. So this column is really a key decision in our implementation. Then it's trust. Of course, I'm going to mention that in my session, so you will see some example when we could potentially face performance issues after implementation of table partitioning if we don't spend enough time before implementation to analyze our queries and to decide if this is a proper option or not. So there is a lot of work before implementation of table partitioning. So I believe at the end of the session, you will know a lot of steps, and we will dive deeper so that you will feel much comfortable for when we try to implement partition. So partitioning is transparent for all queries. SQL Server handles data placement. That's actually one of the best things of partitioning. You don't need to change your code. You don't need to, let's say, decide in which table to insert data. You don't need to put a dynamic code for forcing query to write and to read in a particular table. It's just transparent for the queries, which doesn't mean that we don't need to do anything in our code. Actually, it's probably more or less work is focused work which we should perform is focused on the physical part, the physical layout, the physical design of the table, like indexes, like partitioning key, as I mentioned, like queries, how we perform updates, deletes, inserts, loads into a table, and how we query the table. So we should be really familiar with this in order to continue with table partitioning. So what are the benefits then? We actually choose to implement partitioning and to put some effort on this implementation because we expect to get some benefits out of that solution. Well, the first benefit is probably we can achieve a very fast loading and unloading and archiving data. But this is actually more or less something that we can do in a data warehousing system, like in the data warehousing databases, when we really have a load, not a row by row insert. So a loading is something that we could optimize and we could do it differently. And at this point in time, I have to mention, yes, we do differently. We have to change the code. If we implement partitioning for loading and archiving data. So that's not like a out of the box solution. We have to think about how to adapt the loading and archiving data on a partitioned table. I'm going to show you that in the session. This could be a really good option for an alternative storage for placing historical data. It's a really common problem, I would say, nowadays. When you build an operational data warehouse, you have an intensive OLTP database, let's say, but suddenly you realize that you got a lot of data inserted into your hot tables, and those data are become bigger and bigger, and you start facing performance issues. So it's better to think in advance if actually a partitioning could help for removing or taking out historical data and placing historical data easily into either alternative file group, which you can put in let's say a slower disk, or even to take it out easy from the table and place it or copy it into an archive database, let's say, which you place into, let's say, a slower disk subsystem. So that's really a good choice if you have such a case. Then it gives you an option to enhance maintenance and manageability, because you can choose to perform a different index management compression per partition instead of per table. You can choose to use incremental statistics, let's say per partition and per table. So statistics are updated per partition, which is really good when you have an intensive part of the table with intensive modifications. And another part of data which are like historical data, which potentially you use for querying. So such a solution actually brings you a benefit of splitting users who read mostly the older data and those who modify data. When you have a single table, then those users potentially compete, and you observed a lot of locking behavior. So partitioning allows you to split, divide, and conquer, which means to split those data into a physical parts and to potentially put some different indexes. Some lock escalation management is like lock escalation is on a partition level, not at a table level. So some users can work on a specific partition which contains data, with a heavily modifications, so they can perform that, and other users could use older data to avoid locking and blocking of writers. So on top of that, you got a piecemeal backup and restore. So we had a case like this with one of our customers, and we implemented partitioning for a database which didn't manage to enter into recovery time and recovery point objectives after the database grown a lot. So in that case, we have to be able to restore a database really fast, but the database was like terabyte and a half almost. So it's no way to fit into recovery point objective of, let's say, 2 hours to restore a database if something goes wrong. So in that case, you have to think about a smarter solution of dividing the database in parts and potentially restoring a primary and read-write file group so that you allow the users to connect. And then as a second step, to restore a read-only file group so that you provide users with the historical data as a step-by-step process, which goes out of the recovery time objective, let's say. So that could be a good option if, of course, the workload fits into that. So if you have such data which could be placed in a read-only file groups. In our scenarios, we got like a data for a year. So every single year, we create every year we create a new file group, and we the past year we switch to a read-only. And we perform backup then, and we don't include that in backups anymore. So that could be a good strategy. Well, what about the performance then? So probably everybody expects the partitioning to bring a performance benefit. Well, that could be wrong expectations, because we actually don't implement partitioning just to gain a performance benefit. We gain performance benefit indirectly, like a side effect, because we reduce a locking behavior by splitting users. We manage to perform statistics updates on a partition level. Let's say we get rid of the historical data so that users modify data in the most recent partitions. So this, or we read the data, and Query Optimizer actually manages to force us to drive us to a specific partition, and we work with a less amount of data to run our queries instead of working against the entire table. So just because of that, and when we implement it correctly, we gain a benefit from the performance perspective. So this we have to understand. So partitioning is we have specific reasons for implementing it. Yes, having a big table is probably one of the reasons initially, but there should be something else than just having a big table. So you probably face either locking behavior, you have a lot of historical data, and you potentially, when you do performance monitoring, you realize that your queries run against many data. You probably have, let's say, large weights. You have a lot of intensive IOs, so you IO operations, you read a lot of data. And this slows down your queries. So it could be a good reason for implementing partitioning, but not just a performance problem. So you need to dive deeper to understand the reason behind the performance problem, the root cause, and then if the root cause fits into one of those cases, then probably the partitioning is a good choice. So in the data warehousing, the partitioning is really a good choice when you have to perform a loading and you have to load data in a mass amount of data, let's say on a daily basis into a data warehouse, and you just use partitioning for fast loading, and last but not least, for archiving or deleting of data as well. So those are the main cases. Of course, you can have more, but those are the main cases. And this is something that we have to consider. And then we start diving a little bit deeper into the use case of a specific partitioning. So I'm going to cover that during the session. So let's continue by just diving into partitioning a little bit in order to clarify the do's and don'ts during the implementation of partitioning. And then I'm getting back to should we do it, and what should we consider? So in order to dive into partitioning, we have to consider some specific terms. So I mentioned the criteria, the partitioning key. So the partitioning key is actually a column in the table, which we use for dividing data, for splitting data. Every single value of that column is compared to a value which we put in the partition function, so that SQL Server can compare the values and can decide in which partition it should save our data. So we got a function, and then we got a partition schema. So the function is actually a function, like a user-defined function, for example, that you create, but it's a really specific. It just defines the border values of your partition key. And the role of partition function is to just decide on which partition, in which physical group of file group, the data should be stored. So the partition schema is actually the physical layout of your partition. So where exactly specific partition should be stored, in which file group. So the mapping is performed between a function and between a partition schema. Once we do that, we can perform, or we can use a data movement by we can use alter and switch, merge and split in the data movement scenarios, but we have to perform that first. So let me start by doing like implementing a demo partitioning for a table. So I'm going to share my screen now. And I'm going to show you the demo. Just a second to switch to my screen. Yes, good. Yeah, perfect. Okay then. So I mentioned that the case here, which I'm going to implement. So let's first I'll describe the case a little bit. So we got a table DBO orders, and we have to insert a value. So we decide to split a table into partitions by year. So if we got a column, which is a data key, and that data key has some intervals. So our partition function that I'm going to create, so my partition function will have to specify those values. Those are border values which divide the timeline of possible values of my partition key column, which is a data key column in my table. So that when a new row comes, then the partition function, which I've defined, has to return to SQL Server. So it has to compare this value and has to place that value into a specific time interval. And it has to return the partition ID to SQL Server. So in this case, the partition ID will be number 2, and this will be returned by partition function. Then for SQL Server, the task remains to insert this row into this specific file group, which corresponds to partition 2, which saves data for partition 2. So this is actually defined by partition schema, which maps every single partition to the interval. So I got 4 partitions based on those 3 border values, and I got 4 file groups which map to a specific partition. So it's worthy to mention 2 things here. When you define a partition schema, you have to consider that the first interval, the first partition, will hold the data which you actually don't expect to go there. So if your timeline starts on 1st of January 2015 in this case, then you don't expect to have data which have a date before that date. So if something goes into that partition, the first one, then it should be like by error, by mistake, let's say. Well, there are some practices when you potentially can even define that file group as a read-only, just to be sure that nothing goes in that partition. And when we perform partitioning, we have to consider that the first and last part stays or cannot be dropped, let's say, or cannot be merged, but I will get there soon. So now, how do we do that? How do we implement that? So I'm going to create a database, partitioning demo. So this is my database. Here we go, partitioning demo. And I'm going to create those file groups and files first. So I'm creating that, and I'm saying that this is my first, let's say, system, like a file group. And I got those 3. Good. So now I've created those, and now it's time to create a partition function and partition schema. So what is important when you create a partition function? So first thing is to define the type, the data type. So the data type should match to the partition key column in your table. So that's for sure. Then we got the range right. So this is probably one of the misunderstood partitioning terms and concepts. What does it mean to get a partition right for those values? Well, partition right defines the place for the first and the last partition. So the first partition stays on the left side in the beginning, and you always add partition on the right. So this is actually very important. Defining right here on the range means when I add a new partition, for example, for the year 2018, I'm going to add it on the right side of the time scale. And this partition cannot be removed, let's say. So I'm always merging from that part to the right. So, and of course, the last but not least, which is the starting interval. So in which side of the interval we have an open interval. So in this case, when you use, let's say, a date for partitioning, which is really common because data come by date. So it's good to use, it's like a really good practice to use a range right. So I'm going to probably show you the range left, so you will see why we don't actually choose that. So I'm creating partition schema, as I mentioned, and then I'm creating partition table. So the table, you can rebuild cluster index on the partition, or you can with the drop existing. So you have different options to actually perform partitioning on an existing table. But when you create a new table, including actually loading data from an existing table to the new one. So this is really a simple solution. You just need more storage in order to keep them both at the same time. and load from the existing one. But it's probably the easiest way to implement partitioning of the existing table. So I'm creating table and I'm saying data key is my integer column. I got another column, which is amount, let's say a really simple table just to show the demo concept. So I'm implementing that on PS. What does it mean? This means on partitioning schema that I've just created, and this is my data key. So I'm specifying that I'm running that as a partition table. I'm creating the table with the different habits or the different structures, and I'm using this as a data key. So this will indirectly map to my integer column in the partition function. Here we go. So now I'm inserting some values. Basically, SQL Server will be able to check or to go through the partition function to return the partition number and to insert my data properly into a specific structures like this. Let me query the table and let me specify, let me try to search for a specific partition. So in which partition every single row is. This is a function, a system function, so we can use it. And you can say, hey, give me the details about the partition number. And here we go. So every single record goes to a specific partition, like a partition number. And you got this 3 records into partition number 2. We got 2 records in partition number 3 and just 1 record in partition number 4. Let me give you a little bit more information on how this is structured. So we got our orders table, and what I did just now, I queried the table, and this is my data key, my partition number. So this is the function that you can use for seeing every single row in which partition it is placed, and obviously it works as expected. What I mentioned during the beginning of my presentation is that we got several indexing structures, so several habits. Well, you probably can wonder how this is implemented in the background. So what happens in the storage? So if you imagine the B3 index of a whole table, when you implement partitioning, you actually create several B3 indexes, one for every single partition. So this is a common structure. If you have a clustered index, then you got several root pages. And this B3 structure will actually contain all the data which are just for this partition, which are stored in this partition. So it's like having several indexes and several physical structures into just a common metadata structure, which we see as a table. But internally in the background, we have several habits. And we can see that by using sys partitions and sys system internal allocation units. So I'm going to mention that here. Well, you got a partition ID, which is unique, of course, of this table, which is object ID. Currently, I'm organizing partitions as heaps, so I don't have a cluster index, but I'm going to create one later on. So that's why my index ID is 0. But as you can see, I got a different allocation units ID and different habits in this case. And you can see that I got the first page, the address of the first page, which is different for all those structures, for all 4 structures. Yes, I don't have a root page now because the root page is actually not something that I have in a heap. So in a heap, I just have a first page, which I'm starting with.
When sorry, your screen is frozen.
Okay.
No, it's fine. No, it's fine. You need to refresh. For me, it's working.
Yes,
Okay.
for me too.
Okay, good. So, yeah, what about inserting new data? So inserting new data happens like this. What if I have to go and insert data for the year 2018? So I have to make a place for those data first. So what I'm doing now, I'm creating a new file group and a new partition. Probably this is because I'm switching between those two, but just let me switch again and just give you an idea what I'm doing. Then I'm not going to switch quite often in order to avoid that locking. So what I'm doing now is I'm actually doing this. I'm adding a file group, which is I'm adding a new file. I'm adding a new file group, and in the partition schema, I'm saying this will be my next used file group. Then I have to alter the partition function in order to split my last interval so that I get this interval. And then I get a new one, which stays in the middle and starts from 1st of January, 2018. So that will be my partition number 5. Well, when I do that, I need to be really careful so that I don't have data for year 2018. So that's probably one of the most important things to understand. When you split a partition, it could be a really heavy operation for you if you got the data already, which should be placed in your new partition. So it's important to do this in advance before the new data come. And how this looks like. So I am altering a database and I'm adding a file group. Here we go. Then I'm adding a file, of course. So that's expected. This is the next use. So I'm correcting the schema and I'm saying, hey, I'm adding a new one, and this will be added at the most right of my interval. So now I'm going to run a split function, and I'm showing you that I have just 3 records in the transaction log file now, and I'm going to show you how it looks like if I split partition and I don't have records in 2018 yet. Here we go. And if I run that, you'll see that I will get some records in my transaction log file, 26 now, but all of those records are just happen to a metadata only. So you see that I don't have a table here. So I'm not touching the table and the rows in the table. What I'm touching though is just sys schema, which is just a metadata operation. But in order for that to be transparent and to happen without the IOs, I need to make it before my new data come. And now I got it here. So here is my partition number 5. I've just created a new, let's say, structure, which will be placed with the data. So I'm inserting new rows. So now I will show you how it looks like if we have to split with the data. So this is actually something really important. So I'm going to insert data for 2019. So data for 2019 are actually something that I'm going to insert now, but I'm going to run a split function later on. Here we go. So I got some records here. And then I'm going to alter database, and I'm going to add a file group so that I'm doing the partitioning like this. I'm altering the schema, and now I'm running a checkpoint, and you'll see again that I got the 3 records in my transaction log file, but now I'm going to alter the partition function now. So I have data, and I'm going to split to 2019. Here we go. And if I check this again, you will see that I got a lot more records, like almost 60. And if I run this as a work clause, you can see that some of them are actually running through table orders. So what is happening happening here is I'm inserting, so in the background, it deletes a row from the old partition and it moves them to the new one. So you don't need that. You have to avoid that in your environment. Very, very, very important.
Excuse me, I'm very sorry. We have still the problem with screen.
Okay, then I'm going to switch to the presentation because that's probably will not gonna happen like this, the demo. What you have to do, like, okay, I'm taking this out and I'm going to, so what we do now, I'm going to just like stop the demo now, and I hope you can see the screen now and the split PowerPoint page. So what I've just did, I shown you that splitting is actually something that you have to do on range, which is defined before the new data comes. So this is do's and don'ts on this part, on the implementation part. When we have a merge, so merging is something that is actually deleting the data, deleting the old data. When you perform a merge operation, then use of the older partition will be dropped and removed. What does it mean? So imagine that we have a historical data, which are, let's say, the data for the year 2015. So in that case, we have to be able to split, to remove those data really fast. Removing the data fast means you will have to actually merge the partition number 2 with the partition number 3, so that the new order will be the partition number 1 and the partition number 2 will be for 2016. And so how we do that? We first have to create a new table, let's say, to get the data out. So merging means you get the data out and you can truncate the partition and you can actually merge the partitions into. What is important to consider, so this is actually our endpoint. We alter partition function and we say merge range. So we merge range so that 2015 is out. But if we have to perform that, we have to create a new table. We can actually load data to a new staging table. Then you can truncate the partition so that the partition is empty before we perform a merge. So the empty partition is the one that should be merged, actually. We have to take care about emptying or truncating a partition before that. This we can use and we can have when we do this merging. It's really easy. You actually create a new table on the same file group. So let me get back to the slide. You create a new table which will gather data from FG 2015. You load data, like you perform switch out of your data to a partition, then you can truncate and then you can merge. So really fast without a lot of transaction log file consumption. So that's a historical data movement. Well, what we should do and what we should consider not doing. We don't split a partition if we already have data in it. So we have to prepare that beforehand. In case you miss a split, you missed to split before insertion on new data. We had a case like this in one of our customers. So we have to perform, we have to switch the entire partition out. We have to split the data into 2 new tables. Then we fix the partition function by splitting, and then we switch data back in both partitions. So this will reduce greatly the amount of the transaction log file you generate. due to the splitting of the partition. Switching in and out is something that is really fast because it's a metadata operation. You have to just prepare a table, create a table in advance on staging one, and you define constraints, and you just switch in and out. When you have to remove partitions, then you always check partition records, so the partition should be empty. You can use truncate table to empty partitions so that, for example, you create a new staging table, you perform insert into that table, selecting data from an existing partition. If you want to preserve those data, then you can do that. You can transfer them to a staging table. Then you perform a truncate of a table, of a partition. That's supported in a recent version of SQL Server, so it's really helpful. You don't perform delete, you just truncate the entire partition, you empty it, and then you can merge it. Should we rely on deleting directly into partition table or loading data directly into partition table? Well, better don't do that. Well, I'm not saying that it will not be performed, but if you have to load data, which means you load out fast, like a big amount of data, like for example 100,000 rows at a time or 1 million rows at a time, you don't perform this by using insert statement. You usually use, for example, integration services, packages, or something that is a bulk insert statement, for example, or BCP. So in this way, we can use an intermediate staging table. So what does it mean? We load data into an empty staging table, which is not the partitioned one. Then we perform an indexing on that table. So the indexes and check constraint could match the partition that we want to get data into. Then we perform a switch in, which means we actually attach the table which we load the data in to a big partitioned table. So this is a better way to load and a really fast way to load it. If you choose to insert data directly into partition table, SQL Server will manage that. SQL Server, as I managed to show you at least that in the demo, will manage to insert data properly into a specific partition based on the value of the partition key. But actually, what you will face is like it has to check the partitioning key for every single value, for every single row at a time of loading data, which will slow down the process of loading if you have a lot of data to load. So that's why we load into a heap, which is the fastest possible way to load, and then we switch the partition in. So we prepare a table, we index, and then we switch in. For archiving, we do the same. So we actually create a table and we perform switch out. So we try to avoid loading data directly into a partition table. So we have to consider, probably we have to think about and we have to analyze how many updates and inserts will go to a partition table. So we have to consider that every single insert, when you use an insert statement, will go through the function. So SQL Server has to check the function, compare the value, decide the number of partition, and then to load the data. Yeah, it happens quite fast, but it's not the way to load. It's probably the way to insert data if this table is, let's say, operational. What about left and right? So I mentioned that you have to use arrange right, and it's a common a way to implement partitioning because of two things, as I mentioned. So first of all, you got your new partition on the right, which is kind of like native way to do it. And it comes to the right into the partition schema as well. so that you only perform a data movement in case you got your data already into a potential new partition, which I mentioned several times that you have to avoid. But the left actually means that we have to define the end of the interval, not the beginning of the interval, which for dates is a little bit tricky because of the precision of the data type column. Yeah, you can use integers, but in that case, it's probably not the best solution either. So range left will be tricky, and you can miss a value. You can actually place a value in a different, let's say, partition if you don't specify the precision of the last possible value correctly in your partition function. So this is one thing. The other, probably most important thing is when you add a partition in the range left, the partition is added on the left side of the last one, which means you will add a partition in the schema between 3 and 4. So 4 will be your last one in the schema, not in the function, but in the schema. So that what SQL Server will perform in that case, if you add a partition for, let's say, the year 2017, according to the slide, so you will actually schema before the last one because you use left. So you say, I'm adding on the left of part of the last partition. Well, that's very tricky because what SQL Server will perform in the background is it will actually move all the data from from 2016 to another partition, and it will perform a huge amount of IO operations in the background. So that's really bad. And this is something that you're going to face, which you probably are not aware of. So we generally avoid using range left, and this is probably one of the most important reasons to avoid it. And so in the background, it performs a huge amount of IO operation in every single adding of a partition, which is not okay, of course. So what about, and we don't do that. Again, the range, left or right, determines the partition created by split on which part of the intervals. When you perform right, then it will be on the right, and it will be the new one on the right. It performs the partition, the removal of a partition also is something that is defined by range right. So, or the range itself in the function. And the permanent partition, which can never be removed, is a partition which stays in different places on range right and left. So consider that range left is very difficult to maintain. It potentially could perform a lot of IO operations. Last but not least, what about the indexing? Well, we have aligned and non-aligned indexes in partitioning. And yeah, unfortunately, I cannot show you the demo because I don't want to spend the next few minutes going in and out. But what is important here? Well, when aligned index means you create an indexing structure in every single B tree, in every habit, in every file, in the file group that you perform. So aligned index, it will be created in a specific partition and will cover the partition data only. Non-aligned indexes can be created on the entire table. So non-aligned indexes will include data which are like the whole table data. Well, I mentioned that when we want to implement partitioning, we have to understand our queries. And our queries are actually important to analyze. So you can do that by running extended events, which filter out just a statement completed on an object in a particular database. But you have to be aware of those queries. And the successful partitioning strategy is the one that uses partition key properly, and this partition key is used in every single where clause that you run in your table. So, for example, what if I run a where clause in my table which says, let's say, select the star from the table and where data key equals to something. Then if I use my data key as a partition key in the where clause, SQL Server will manage to just scan a single partition or perform an index seek, but just it will consider a single partition only. And that's the performance benefit that you will achieve, because you will manage to focus on a single B tree only, not on an entire table. So this is actually the main important thing in partitioning. What if you don't use a data key, but what if you run a query on your orders table and you say where amount equals to something, and you miss the data key, you don't have it in the where clause. So in that case, you have to scan the entire table. So you have to consider scanning. So SQL Server will perform scanning of all the partition one after another, and it will not be a location scan either. It will be just getting to one single partition, then getting to the next one, then getting to the next one, and scanning, which actually will be even more expensive than if you don't have a partitioning. So in other words, very, very important, if you consider partitioning at all, then you have to make sure that all of your queries, which at least the most heaviest, actually almost all of the queries, have this partition key in the where clause, or you have to put it there, because otherwise you will have more performance issues than before you implement partitioning. Very, very important. As a workaround, you can create a non-aligned index. For example, in this particular case, I could create an index which is on non-cluster index, for example, on orders amount, so that it will perform, let's say, it will build an index on an amount column as a leading column of the index, and it will have a primary key or cluster index key, like data key, as my second column. So it will be able to use that as a mapping between the column that you use in the where clause and the partition key column. You create such an indexes as a common practice in the primary file group, and you actually use them during the queries which do not require where clause. Well, that's probably a workaround, but it will prevent you from using the main features of partitionings like split, merge, switch, because this index will actually, you have to drop it first on every single operation like this, and then you create it again. So, and if you have, let's say, 10 years of data in a read-only partitioning strategy, then the DB layout and backups, everything is set up. So it will be challenging for creating this such indexes. Good. So we have to really be careful on that case. So. That's it for a partitioning. As a review, in implementation, you got some do's and don'ts, so make sure you align with them and you use them in order to avoid problems in the future, because it's not an easy maintaining a solution. You have to eliminate the IO operation as much as possible and the transaction lock records. And if you really want to consider partitioning, it's not just the size that matters in this case for your table. You have to understand your queries, and you have to consider how those queries will behave. If I have several B tree structures, Good. Thank you all for the session. I'm sorry for the technical issues. And no changes. You can download the presentation without any issues. And yeah. Okay. Thank you.
Thank you very much.